Hello students, let us continue our discussion on formulation of LPP. So I'll take up a few more problems and I'll also ask you to solve a few problems so that you can understand the things better. So on a diet problem that I had told you about is, as you can see on the screen, so there are three types of foods, say X, Y and Z. Okay, food X contains 6 units of vitamin A, 7 units of vitamin D, vitamin B and 3 units of vitamin C per gram. Okay, and costs 12 paisa per gram. Okay, so that is around 100, cost of 100 gram is around 12 rupees. Okay, so it's 120 per kilo. Okay, for food Y contains 2, 5 and 3 units of these vitamins respectively and costs 5 paisa per gram. Okay, so that is 50 rupees per kilo, right? And food Z contains 8, 12 and 6 units of these vitamins and costs 20 paisa per gram. Okay, that means 200 rupees per kilo, right? So the daily requirements of vitamins A, B and C are at least 100, 150 and 80 units respectively. Okay, so we need to formulate the problem as an LPP to minimize the cost of planning the diet. Okay, so it is assumed that the person who is taking these diets takes only these particular food items per day. Okay, that is one assumption, because we are given only this three types of foods here. Okay, so one is food X, another is food Y, another is food Z. Okay, so each food contains different amounts of vitamin A, vitamin B, vitamin C. Okay, so let us try to formulate this as an LPP. Okay, so first of all let us write that how many units of food. Unit means here it's gram, the unit is gram. Okay, so let us, instead of writing units, let us just write grams. Okay, so let X grams of capital A, then Y grams of capital, sorry, not capital A, it's capital X. Let X grams of capital X, comma Y grams of capital Y and Z grams of capital Z be consumed. Okay, consumed per day, consumed per day. Okay, then what is the total cost incurred? The total cost incurred will be total cost will be, so let us note by Z only. It's so first one costs 12 paisa per gram, so we are consuming X grams, so it's 12X, plus the second one costs 5 paisa per gram, so we are consuming Y grams, so it's 5Y, and the last one is 20 paisa per gram, so it's 20Z. Right, so the total cost is this, so this is given in paise. Okay, and then the other restrictions: food X contains 6 units of vitamin A, food Y contains 2 units of vitamin A. Okay, and food Z contains 8 units of vitamin A. So it is assumed that the person is eating all these three types of foods, so the total amount of vitamin A that is taken by the person will be the sum of all these. Okay, so what is that? 6 units of vitamin A. Okay, so total units of vitamin vitamin A consumed, okay, consumed will be equal to, so the first one contains 6 units per gram, okay, so we are consuming x grams, so it is 6x. The second one contains how many units? 2 units per gram, and the third one contains 8 units per gram, so it's 6x plus twice y plus 8z, okay. This is the total units of vitamin A consumed. Similarly, total units of vitamin B consumed is equal to 7 units for the first one, 5 units for the second one, and 12 units for the third one. 7x plus 5y plus 12z, okay. So this is the total units of vitamin B consumed, okay. Then the total units of vitamin C that is consumed is equal to what? The first one contains 3 units of vitamin C, the second one 3, and the third one 6, okay. So 3 3 6, so it's 3x plus 3y plus 6z, okay. This is the total units of vitamin C consumed. So as per question, we need at least this much units, 100, 150 and 80 units of vitamin A, B and C, okay. So the given problem, or as per question, at least 100, then 150 and 80, 100, 150 and 80 units of vitamin A, B, C are required, okay, okay. So we can formulate this problem as an LPP as, so the given problem as an LPP is, so I have to minimize the cost, since it is the cost, so minimize z equal to 12x plus 5y plus 20z subject to the constraints 6x plus 2y plus 8z. This should be greater than or equal to 100, because we are consuming at least, means we want at least 100 units of vitamin A, okay. Then the second constraint will be 7x plus 5y plus 12z should be greater than or equal to 150, okay. And the third one should be 3x plus 3y plus 6z is greater than or equal to 80, okay. And the last constraint that is always there is the non-negativity constraint, x, y, z should be greater than or equal to 0, okay. So this is the solution, not the solution, the formulation, mathematical formulation of the given problem, okay. So I hope it is clear. So you can always have a look once this broadcast is over. You can again repeatedly look at the solution and try it yourself. Please do it yourself, don't just look at the video, okay, and think that just before exam you will have a look. That way you cannot learn. You have to do the problem yourself, okay. So I give you this problem. This is also a similar problem. You can try it. A person requires at least 10, 12 and 12 units of chemicals A, B and C respectively for his garden, okay. So he is maintaining a garden, and at least this many units of chemicals are required as fertilizers for his garden probably. So a liquid product contains 5, 2 and 1 units of A, B and C respectively per jar. Okay, and a dry product contains 1 to 4 units of A, B, C respectively per carton. So if the liquid product sells for 3 per jar and the dry product sells for ₹2 per carton, then formulate the problem as an LPP in order to minimize the cost and meet the requirements. Okay, so immediately I'll just give you some hint. Please try to complete it yourself. That you take, say, X jars of capital of the liquid product, right? Of the liquid product are used. Okay, product are used. Okay, and Y cartons. So here, since the units are mentioned, so we have not written it as units, instead we have written carton. Okay, so X is in the liquid product is in terms of jar and the dry product is in terms of carton. So Y cartons of dry product, okay, dry product are used. Okay. So you can begin it with let. So what is the cost incurred? Cost incurred is Z equal to 3 per jar, so 3x plus twice y. Okay, so this is in rupees. And what are the restrictions? The restrictions are chemicals A, the amount of chemical A that is obtained is what? 5x plus y. Okay, this has to be greater than or equal to 10. You have to understand this, in which case it will be greater, which case it will be smaller. You have to understand this from the question itself. Here it is mentioned that the person requires at least 10 units. Okay, so minimum, at least 10 units means minimum he requires 10 units of the chemical A. So 5x plus y has to be greater than or equal to 10. Okay, it cannot be less than 10. Right, that is the restriction. The chemical B is twice x plus for the dry product it is 2. So again it's twice x plus twice y. This should be greater than or equal to 12. Okay, so no need to cancel out. You keep it as it is. Okay, we don't have to cancel out the 2 and simplify it. Okay, no need to simplify. Even if you simplify, it's not a problem because it means the same thing. And then for the chemical C, it will be x plus 4y. This has to be greater than or equal to 12. And the other restrictions are x, y, z should be greater than or equal to 0. Okay, so please write it nicely in language so that it is presentable. So in exams also you have to write all the details, somewhat similar to whatever I have written here for the first problem and for the earlier problems that we had done in the earlier 2 lectures. Okay, so this is a idea of this the formulation of this particular problem. Okay, you can have a look at another one. So 3 different types of lorries A, B and C have been used to transport 60 tons solid, 35 tons liquid substances. A type lorry, so there are 3 types of lorries, A, B and C. Okay, A type lorry can carry 7 tons solid and 3 tons liquid, and B type lorry can carry 6 tons solid and 2 tons liquid, and C type lorry can carry 3 tons solid and 4 tons liquid. So the costs for transportation of these are 500, 400, 450 per lorry of types ABC. Okay, so I do not know how many lorries are used, so I can always assume that so instead of writing x, y, z, you can also write something like let x1 lorries means trucks. Okay, lorries of type A, then x2 lorries of type B, and x3 lorries type C be used. Okay, be used. So what is the transportation cost? Transportation cost is equal to 500 x1. So for each lorry of type A, the cost is 500. Okay, so we are using x1 lorries of type A, so it's 500 x1 plus this is 400 x2 plus this is 450 x3. Okay, so this is the total transportation cost. And what about this carrying capacity? A type lorry can carry 7 tons solid. Okay, so and B type lorry can carry 6 tons solid, and C type lorry can carry 3 tons solid. Okay, so what is the amount of solid that is carried? Amount of solid carried by the lorries is equal to what? A type lorry can carry 7 tons of solid per lorry. Okay, so 7x1 plus B type can carry 6 tons, so it's 6x2 plus C can carry 3 tons, so it's 3x3. so this is the amount of solid carried. Okay, so if it is not visible, let us go to the next page. Amount of lorry that is being the amount of solid carried. Okay, amount of solid that is carried is equal to what? 6 tons from here, 7 6 and 3, 7 6 3. So it's 7x1 plus 6x2 plus 3x3. And similarly, amount of liquid product that is carried is equal to what? A can carry 3 tons liquid, B can carry 2, and C can carry 4. So it's 3 to 4. 3 to 4. 3x1 plus 2x2 plus 4x3. Okay, so what will be the mathematical formulation? Since it is cost, we have to minimize the transportation cost. So it's minimize 500x1 plus 400x2 plus 450x3 subject to the constraints subject to the constraints 7x1 plus 6x2 plus 3x3 has to be has been used to transport 60 tons solid and 35 tons liquid substances. Okay, so the total we are transporting this. So here nothing is mentioned about at least or at most. Okay, we are 3 different types of lorries are used to transport 60 tons and 35 tons liquid substances. Okay, so that is exactly right. So we can just use equal to here. So the total amount of solid that is being transported has to be exactly 60 tons, and this is 3x1 plus 2x2 plus 4x3. This is also exactly equal to 35 tons. Okay, so equal to 35, and x1 x2 x3, this is greater than or equal to 0. Okay, so you have to understand from the question that what will be the nature of these constraints, whether it is less than or equal to, or it is equal to, or it is greater than or equal to. Okay, in the first problem you see there is something called the daily requirements of these are at least 100, 150, 80. Okay, so in that case it won't be equality. Okay, or in the earlier lecture also we have seen that it can produce at most this many. Okay, so that is not exactly. So if it is mentioned that exactly this many has to be done, then in that case you can use the equality constraint. Okay, So this is also an LPP. It's not necessary that always you should have something like greater than or equal to or less than or equal to. You can have equality constraints as well. Okay, so that's not a problem. So in fact we'll see in simplex method how to solve this simplex method, big M method, when we do how to solve LPPs having this equality constraints. Okay, so this was about formulation. So I hope you can do this formulation part, right? Next, one important thing which I wanted to discuss was about graphical solution. So before discussing graphical solution, I want all of you to understand how to plot straight lines. Okay, and I hope many means in your school days also you have plotted straight lines, something like say x plus twice y equal to 2. Okay, how do we plot this straight line? So I am sure many of you will immediately start making tables of this type, x, y, and then put some values like 0. If x is 0, then what is y? Y is 1. If x is y is 0, then sorry, if y is 0, then what is the, if y is 0, then x is 2. Okay, like that. And then you will also put something like x is 4, then y is, if x is 4, then y is something like -1, right? -1. Okay, so in fact, yeah, this is the correct way of doing, but it's a long and unnecessary way of doing because we already know how we can convert this equation to a intercept form. Okay, you divide both sides by the LCM of by the constant term. Okay, divide both sides by the constant term. So what you get, x by 2 plus y by 1 is equal to 1. Okay, and whenever you have an equation of this type, x by a plus y by b equal to 1, it actually means that this is a straight line which passes through, it is a straight line which passes through the point a0 and 0b. Okay, so something like this. This is the point. Oh, sorry, I have to shift it here, otherwise you will not be able to see. These are the axes and you need to plot. Okay, so suppose I have plotted it somewhere here. Okay, so this point, this is actually a0, the point on the x-axis, and this point is the point 0b. Okay, so x by 2 plus y by 1, it is a straight line which passes through the point 2, 0 and 0, 1. Okay, so similarly if you have something like twice x minus y equal to 4. Okay, so how do you draw this particular straight line? You do it like this: x by, you divide both sides by 4, so it's x by 2 minus y by 4 is equal to 1. Okay, if I want to convert it to this intercept form, I'll write it somewhat like this: x by 2 plus y by minus 4 is equal to 1. Okay, so the x intercept is 2 and y intercept is minus 4. Okay, so any straight line which is not parallel to x-axis or not parallel to and not parallel to y-axis can be converted to this intercept form. Okay, and in particular, if you have a straight line which is parallel to y-axis, its equation will look something like this: x equal to k. So this is a straight line which is parallel to y-axis. Okay, this is a straight line which is parallel to y-axis, and y equal to k, that is a constant. This is a straight line which is parallel to x-axis. Okay, this is a straight line which is parallel to x-axis. Okay, so So suppose I want to draw this particular straight line here, this one, say I want to draw this straight line. So 3x plus twice y is equal to 6. Okay, I want to draw this particular straight line, 3x plus twice y equal to 6. So what I'll do, I'll convert this straight line to the intercept form. So it will be like so it's 3x plus twice y equal to 6. So if you convert it to the intercept form, it's x by 2 plus y by 3 is equal to 1. Okay, so the x intercept is 2, y intercept is 3. So immediately I can draw this particular straight line. So it passes through 2 0 and it passes through 2 0 and 0 3. Okay, so this is the point 2 0. Let me choose a line through 2 points here. It is the straight line which passes through 2 0 and 0 3. Okay, so this particular straight line, this is the straight line which is 3x plus twice y equal to 6. Okay, suppose I want to draw another one, that is okay, suppose I want to draw another straight line, that is 3x minus twice y equal to 6. Okay, so how do I draw it? It passes through, so if you convert it to this intercept form again, it's x by 2 minus y by 3 equal to 1. Okay, x by 2 minus y by 3 equal to 1. So it's x intercept is 2 and y by minus 3, y intercept is minus 3. X intercept is 2 and y intercept here is minus 3. Okay, so this is the straight line that is being drawn. Okay, so that's how you draw it. So you may be wondering, what if this particular constant is not a multiple of the coefficients? So then also there is no problem, we can always draw so just the coefficients or intercept that we will get will not be a integer, it will be some sort of fractions. So if it is something like say 3x plus 2y equal to say 7. Okay, so it's 3x plus twice y equal to 7, or say something like minus 3x plus twice y equal to 7. Okay, so the x intercept is minus 7 by 3. Okay, and the y intercept is 7 by 2. Okay, so 7 by 2 is something like 3.5. So it's a straight line which passes through this 3.5. Y intercept is 3.5. 3.5 and the x intercept is minus 7 by 3. So 7 by 3 is something like 3 2 is 6 and 3 9. So it's minus 2.3 or something like that. Okay, just wait, just do it again. Wait. Okay. Okay, so it passes through 7 by 2. 7 by 2 means 3.5. Okay, so somewhere here 3.5 and 2.33. Okay, 2.33 is maybe somewhere here, minus 2.33. Okay, so that is the straight line. Okay, so you should all know how to draw this type of straight lines. So given any equation, you can always find out the straight line very easily. Okay, just find out the intercepts. So in your exam of LPP, so actually you have many of you, I think most of you have already done this LPP graphical solution in your higher secondary. So in higher secondary already there is a chapter on linear programming, and the graphical solution is also a part of that. Okay, so it's already a known thing to you. Okay, so while drawing the graphs in the question in the examination also, please make sure that you mark the axis. Please make sure that you mark this axis very precisely, and the distances of along the x-axis or the tick marks, okay, should be equidistant along x-axis and y-axis, because the for the graphical solution we need that the graph should be perfect, otherwise you will get a different solution altogether. Okay, if you mark the axis differently, if the spacing is not proper equal, then you may get an incorrect graph. Okay, you may get that the two lines are intersecting somewhere else instead of this. Okay, so suppose actually it happens that the lines are intersecting at this particular point, but if you do not mark the axis nicely, you may get a different thing, that they are intersecting somewhere here. Okay, so that will affect your result of the graphical solution. Okay, so it's very important to draw the graph neatly and mark the axis in an equidistant manner. Okay, so this was about plotting straight lines. In the next lecture we will see how do you plot the inequations. Okay, if I have something like x plus y less than or equal to 8, okay, so how do I represent it graphically? So in this case it does not represent a straight line, it actually represents a part of the plane separated by this particular straight line, if the equality is there. Okay, by the straight line x plus y equal to 8. Okay, so any straight line actually divides the plane into any straight line actually divides the plane into two different parts. Okay, so which part is representing less than or equal to, which part is representing greater than or equal to. Okay, so this is a question we will see, or how to determine this, which part represents what. Okay, so that will be done in the very next lecture tomorrow. Okay, so as of now you please have a look at these problems and try to solve this on your own. Okay, thank you.